DM Radio, the world's longest running show about data. Each week, host Eric Kavanaugh interviews the brightest minds in the world of information management. Want to be on the show? Send an email to info@dmradio.biz. Now, here's your host, Eric Kavanaugh.
Longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanaugh, here with a couple of all-stars to talk all about Kubernetes. Yes, Kubeflow, that was the conference. KubeCon now they call it, I guess. We went to a few months ago. It's amazing stuff. So what is Kubernetes? We're going to find out. We'll talk to my good buddy Sarbjeet Johal, an industry analyst, and also Marino Wijay from a company called Solo.io. But Kubernetes, in short, is, like I call it, the de facto operating system of the cloud, and not just of the cloud. It's sort of the de facto operating system of the next generation of applications, of enterprise applications. So the software that runs your business, or that runs big businesses and a lot of medium-sized businesses these days, the new apps, many of them are being written for Kubernetes, which is basically an orchestration engine. So if you think about your computer, when you load your computer and you load an application and you do things, I often use the spell check as a sort of example or a metaphor. Spell check can be used on different applications. It doesn't have to just be used in one application. You can use it in Microsoft Word or Excel or other places typically. And that's an example of a service. So the spell check is a little engine that has the dictionary in it. That would be a very big service, quite frankly, but it's just an example of a function within an application that does some things you want it to do. Well, with Kubernetes, what they figured out is, look, let's just have these containers, and Docker started this, have these containers that have system processes in them, and then we'll fire off the containers as we need them. So it's much more of an orchestrated approach to delivering functionality as opposed to the traditional monolithic approach. So big software companies like SAP, for example, that is a monolithic architecture. It's this big honking thing that they've built with lots of moving parts, and it does what businesses need it to do, basically, whether that's supply chain or procurement or whatever. You have these big monolithic applications. That was the old way of doing things. And the new way of doing things is much more distributed. It's much more federated, and it's much smaller. So Kubernetes, which is an open source project that came out of Google, an absolutely brilliant project as far as I'm concerned. And it's really abstracted away the need to worry about the operating system. So it's running on Linux, the open source operating system. A lot of applications run on Linux these days. But the point with Kubernetes is that it is OS agnostic in that sense, meaning you don't have to worry about what the operating system is at the endpoint. And that was a very clever move by Google. And now it is just taken over, and it's the sort of de facto OS out there, which is just amazing stuff. Now, there are all sorts of other issues that have sprung up around that. For example, observability, just kind of knowing what's going on out there. And there are like 40, 50 observability vendors now, because that's how important Kubernetes is. And of course, security is another challenge to tackle, because it is a more complex environment. It's not a very easy thing to set up, but there are lots of vendors out there helping you set that stuff up too. So lots of things are happening. And to start us off, I'll bring in our good buddy Sarbjeet Johal. And there is some news of the day we've been musing before the show. There was an open letter that's been put out there, and Elon Musk signed it, and some other folks signed it, asking for a 6-month pause in the development of artificial intelligence, or of big AI experiments, is I think how they described it. And, I love Elon Musk, and I agree with almost everything he says, but this one had me scratching my head a bit. I'm thinking, what are you talking about? Like, there's just absolutely no way that people are just going to stop. Like, okay, boss, we got to stop. I mean, you think about the amount of money that gets poured in from venture capitalists and other investors to these companies to do stuff. And what, you're going to tell them, sorry, guys, we've got to wait another 6 months to get some ROI? Absolutely no chance of that happening. Now, I think we do need legislation, quite frankly. I think we need legislation that calls for transparency in the algorithms, because these are very powerful engines. And if you ask ChatGPT which database it uses, which I did, it won't tell you. It says, well, I can't tell you that. I have to be secret about all that. Well, explainability, hello. Explainability is a really important aspect of artificial intelligence. And if you can't explain how your engine came to some conclusion, you might wind up in trouble with regulators. So it's going to be a really interesting battle over the next 6 to 12 months or 5 years, whatever, in our industry. But with that long-winded opening, Sarvjit Johal, welcome back to the show. What do you think about all the latest?
Hi, Eric. I'm glad to be here. Yeah, it's a wild, wild west in technology space these days. As you know, there's a lot like Microsoft teams up with OpenAI, and then Google gets pressured, and they release something, and then Microsoft comes back with two more like a it's like a boxing match, two big punches, and we're going to fix security with this, and we're going to fix software creation with this, and we're going to fix how artists create images and videos with this. So Google is trying to play catch up, but at the same time, Google has a lot more to lose than Microsoft in this case. Like Microsoft was an underdog in on the
Right.
search side and so forth. So then I think this battle will go on, and there are a lot of other ancillary sort of industry around it, which will suffer if we can't figure out things fast enough. I said this actually just a day after they released the chat GPT. I sat with Dave Vellante and John Furrier in their studio here on the Cube, and I said this is premature release, and they shouldn't have released it at that point, I believe. And then they pressed the pedal on it. I mean, like we can talk about it some other show, but
Yeah, no.
so
No, they did they hit the gas, and I think there wasn't, first of all, enough education, right? Because a lot of the concerns that have been spun out are, oh my goodness, it's sentient, it's going to come alive, it's saying that it wants to be alive, it told the New York Times reporter it loves it and everything, and leave your wife and all this stuff. But people don't realize this is a large language model. It's not a sentient being. It's a large language model whose job it is to predict what it thinks you are going to want to see, right? So it's trying to just give you words back pursuant to a prompt that you provide. And the point there being, these reporters who are asking it all these existential questions were really kind of misusing the tool, right, Sarvjit?
Yeah, it will give you wrong answers many times, and with high confidence, it will say things. It's a best bullshitter in many ways. So in many ways, it gives you the great answer. It's the best answer you can get. It's a collective knowledge it has access to. But in some cases, like when you ask very deeper intellectual kind of questions, it will give you some BS. It will cook up some quotes on other people's behalf, which they never said. I mean, it's all over the place. It's not a very reliable system. It's not. You can't take the output from those APIs and give it to a robot to do things. You can't. You have still need human in the loop who is well informed to make sure if that thing is right or wrong. It'll give you some boilerplate code, boilerplate, text for creating a document, boilerplate thought process. Yeah,
Right.
it's a good step forward, but it's not something you can use in production to start with.
Yeah, well, and like it kind of speaks to the amount of innovation we're seeing out there in the marketplace. Now, Kubernetes, of course, is a sort of infrastructure style technology. And what I mean by that, it's very foundational, right? And so AI is going to sit on top of some of these things because AI will run in engines that are built to work with Kubernetes, right? So I think K8, as some people refer to it, is an enabling technology. And this AI tech that we're all working on now, it does have very powerful value if used properly. And I think that's the key, right? Is the proper usage. And there, here we go again with a disconnect between the mainstream media and major powerful technology disciplines out there in the marketplace, right, Sarvjit?
Definitely, actually, the whole idea behind automation is all along since we invented fire and wheel and whatnot, lever, is to take the human out of the loop or make humans' job easier, right? So that's the whole idea. Kubernetes is another step in that whole long sort of way where we are right now. So the hardest part for us was to manage all these servers, physical servers. So from there, we went to virtual machines. Then the virtual machines were hard to manage, and then we had mechanisms to, you know, contain those environments, right? But then containers came in, which is even a minute level concept from server to VM to container, which helps you slice your operating system into many compute units, if you will. So it's, as you said, it's operating system agnostic. It sits on top of operating system and takes advantage of the IO of the what IO services of the operating system, what it provides, and maps it to the containers, like small chunks of compute, if you will, right? Which you can programmatically create and destroy, right? So that's a key. So what Kubernetes does is that you give it a desired state for an application, it will spin up or down the number of VMs needed for the number of containers you need to run the application at certain performance. You know, you can, there are different criteria for the performance. So it takes the human out of the loop. Like human doesn't have to sit there, oh, I need how many VMs, I need more, you know, bandwidth here. We need more, you know, we need to spin up more servers so we can have more VMs. At the end of the day, it sits on top of VMs and their physical servers, but it just manages all that by itself. And with the combination of the cloud, public cloud, which is like pay as you go, or you just don't, it's capex to opex stuff, and you're not buying the servers, right? You're using somebody else's server. The combination of that and Kubernetes is a perfect combination for a lot of workloads. Not all the workloads, I believe, but for a lot of workloads. Because after the Kubernetes, the next thing came was the serverless. So even the minuter or smaller unit of compute, which is serverless, and that has its own applications in some cases, but we can talk about it if we want to go deeper into like how we cook up the microservices and versus like how we use the serverless and microservices sort of context.
That's actually a great thread to pick up on. So let's do this. Let's bring in Marino Wijay from solo.io. Just find out from him what he's been working on. He's got a Kubernetes logo on his shirt too. You got to love that. You got to bring out the K8s because it comes from the steering concept, right? It's a Greek word, I think, for steering or something like that. Marino, tell us a bit about yourself and what you're doing in the Kubernetes world.
Yeah, thank you so much, Eric and Sarjeet. I appreciate, giving that background altogether of Kubernetes and what it's doing in the ecosystem today. So I spend a lot of time working with the community as well as various folks that are interested in learning about application networking, and this is through the lens of Kubernetes. So in Kubernetes, you have containers. Containers need to talk to each other, and they need a pathway to be able to talk to each other. Mm-hmm. But once you've gotten past that pathway, there are also additional concerns like how do we layer in some zero trust? How do we layer in the ability to do things like a canary rollout, a newer version of our app, for example? How do we layer in elements of observability? And so what Solo has been up to is providing all of these application networking and meeting all of these application networking needs for Kubernetes through things like service mesh, backed onto something called Istio, an open source service mesh, as well as Envoy, a very powerful, high-powered proxy that's been around for a long time and was basically built by a company called Lyft. And they started to realize that they needed to build out a pattern where they can understand how services were communicating with each other. So they were the first ones to present this sidecar pattern towards workloads. And it's interesting because we've seen this growth, we've seen an evolution of this technology called service mesh to accommodate for a variety of workloads, virtual machines, containers, workloads that exist outside of the realms of Kubernetes, and even layer in additional features like how do we address policy? We have policies to say, this particular service can do a number of actions against this other service. And so as we're trying to get granular, Solo has basically provided a platform to address areas of observability, traffic management, and even security, because these are the three tenets that you're always going to come across whenever you're operating environments with Kubernetes and containers. So what I've been really up to is will head out to conferences and deliver talks about what service mesh can offer you as value. I'll also spend time with the community to just hop on a live stream, very similar to what you're doing here, and educate folks by just diving into a technology and getting hands-on with it. I think it's important because when you start to empower and educate a community of folks that haven't really seen this in action, they start to realize the value of it and how they can solve these problems within their own environments too, especially when it comes to multiple cloud environments, because we know how messy that can get.
Yeah, no doubt about it. And of course, we have this really challenging topography these days where you've got on-prem data centers that are extant all over the world. You've got cloud computing, which is really taking off. Amazon Web Services, Microsoft Azure, Google Cloud Platform, plus Rackspace, Oracle, other guys are in the game too. And then you have, and you referenced this, the edge, which is this other sort of nebulous, remarkable landscape out there. And so we have people trying to figure out, how do I write applications? How do I persist the data? How do I ensure performance on this functionality across this entire spectrum, which is a very big deal. So from an architectural perspective, and we'll pick this up after our break coming up here, but from an architectural perspective, there are so many more ways to do things these days. You could have an edge first approach, for example, which some companies are doing, where you bake some functionality out there at the edge to do a little bit of number crunching or a little bit of analysis, and then go, aha, and then send some signal across the wire back to a data center or to the cloud somewhere to trigger an action there. You got technologies like Airflow and Airtable, for example, designed to allow you to design these workflows. It's really quite fascinating, but performance is always going to be key, and you need durability and security and all that stuff. We'll pick it up after the break. You're listening to DM Radio.
DM Radio. Here's your host, Eric Kavanaugh.
Back here on DM Radio, talking to Sarjeet Johal, industry analyst, and also Marino Wijay from Solo.io, all about Kubernetes and the cloud and the future of enterprise computing. And of course, as one of my favorite futurists would say, William Gibson, he wrote, the future is here already. It's just not evenly distributed. I love that expression because it just speaks to these pockets of innovation that then radiate out and change the world. And that's happening right now. Silicon Valley, of course, has been the epicenter of much of that change over the past 40 or so years. And the collapse of Silicon Valley Bank notwithstanding, I think it's going to remain an epicenter for quite some time. But in the break there, we were just talking with Sarjeet, and he's making a good point that, there's a certain prudence in the speed at which you roll out innovation, let's say. And he was musing that when ChatGPT was first unveiled, he said that was premature. You guys should not have unveiled it in that particular state. And of course, there were some bad things that happened. And the same holds true for Kubernetes. And you were just saying a moment ago with CMDBs, can you describe what that is and why it matters, the fact that we don't have it now in the cloud?
Yeah, the CMDB world, actually, it's maybe I sound old with that. I'm old. Not that old though, but CMDB stands for Configuration Management Database, and that database was supposed to keep all your configuration items, including your servers, virtual machines, and even the laptops and from the IT side, and desktops and all kind of stuff you have in an enterprise in a database. And on the back end, the relationship between servers, like what's running where, the operating system, which server has what operating system and what applications are installed where. So it was supposed to have the whole 9 yards, and it came from the ITIL world. It came from the UK government, the whole sort of discipline, and it took over the US market for some time. And IBM had a big product there. HP OpenView was a big product, and their CA CMDB was a BMC Atrium. Those were the four main products in that era. And I used to work on these sort of integrations. Like we had our own observability solutions back then, right? And then we'll put all the data into CMDBs, and from there we'll get the intelligence about the security and all that stuff, like what we need to do where, right? But we don't have that facility in cloud right now. Actually, the pace of change is such that we can't keep up with like the changes being made to the CIs, configuration items. It can be anything things, server, VM, container, so it's a problem, I believe, in the it introduces the problem. Actually, I usually say that technology is like medicine. Every pill has a side effect. So we have taken the cloud pill. It has a lot of side effects, and under the cloud pill, there's a Kubernetes pill, and that has side effects, right? And the side effect of that is that how do you keep track of all your containers, where they are, what they are doing, and how they're interconnected with each other, what protocol they're talking on, what port they're talking on, is that safe for them to talk through that port? Is it open to the public? Is it closed? Do you have certs for that? Which application can get to it? So all kind of stuff on the networking and security side. Bringing it back to our discussion. So the networking is very sort of complicated area in the modern cloud world, especially when it comes to Kubernetes. And along with that network goes the security. So that's an area where we need to do more work in. And then we are doing that work through Istio, and we're in many other projects which are not that visible. But Istio as a service mesh took, it became the number one service mesh. It's CNCF project, and a lot of people started building around that. So we still need to simplify things even in the Istio world. That's how I see it. And because I have coded a bunch of platform level services back then, working at different companies, PeopleSoft to Oracle to Rackspace to VMware, and knowing the nature of the beast, there's always a chance to simplify and improve performance and improve economics as well. Actually, I think we have focused a lot more on the economics than the security and scalability and the manageability of the systems. And I think right now we have to contain that so we have to work on the manageability of side of things. Like we have to get the control of the situation a little bit.
Yeah. And, I'm going to bring in Marino Wijay here again from solo.io. And Marino, as we're talking about this, and Sarabjit makes all these excellent points, especially around the networking side. Of course, that's your area of expertise. I remember explaining to my parents over dinner like 12 years ago about Ajax, right? Remember when Ajax came out, asynchronous JavaScript and XML? And I said, look, it's basically like you go to the store and you buy all these products and you come home, but you forgot one particular product. Well, you don't have to drive everything back to the store and get it back all to your house again. Just go get that one product, right? And that's kind of how Ajax worked. It seems to me the principle that drove Ajax is also very useful in networking. But what do you think about that, Vijay?
Yeah, so networking is going to be foundational for everything that we do, whether it's working with containers, working with cloud environments. It's just sometimes we might see it, we might not have any control over it, or it might be the opposite. We don't see it, but we have complete control into this environment that is, okay, how do we dig in and actually find out what's going on? So there were patterns that we saw many, many years ago that made its way into the world of Kubernetes and cloud native. The first pattern was, okay, if I need to connect a bunch of systems together, I'll deploy a switch. Pretty easy, right? Deploy a switch, cable everything up, and now you have a little network going on. But once you started to need to get to those remote networks, you throw in a router, you can route to these different networks, you throw in an internet gateway, you can get out to the public side, and then you have full communication. But where the challenge started coming about, especially with the rise of containers, is you have thousands upon thousands of these endpoints that you need to connect. So it's not very easy to connect all of these endpoints because there's so many of them, they're doing so many different things. And then, oh, by the way, sometimes some might just disappear and then come back later on, right? And this could be just due to our systems that we've deployed. But here's the other thing too. I mentioned that we have no visibility into the network at times, and that also means we cannot predict when things can go wrong in the network. So we have to work around that. We have to work around situations where all of a sudden our ping time is like 500, going from like 5 milliseconds, which actually impacts your line. If you have like a 10 gig line, that 500 millisecond ping has a massive impact in a negative way towards that link. And so you think about this for situations where you're trying to replicate storage, right? If you're doing synchronous replication and you have a miss, well, now your two storage arrays are out of sync. And this is a problem that was witnessed well in the days of storage array networks or SANs. That same problem exists today, but we have to work around that problem. If it's not available, we'll build for the fact that it's not available anymore. And this is what Kubernetes actually offers. So as a distributed system, underneath the hood, it's still using networking to basically make sure that all these different components communicate either through IPC or through an actual network. And where it becomes very interesting is that if the network suddenly becomes unavailable, if something changes, if someone pulls a plug, who cares? We should be able to work around that. Your application should be able to accommodate for that. But we started to hit particular limitations because what we didn't want to end up doing was having to inject our security right into our code. We didn't want to have to create manual routes for every time we tried to figure out where something needed to go.
Right.
We also didn't want to have to sit there and log into every single pod for some level of observability. So this is where service mesh patterns started to come about. So service meshes like Istio, for example, really address these particular areas. You try to figure out where you're trying to go, well, we could tell you how to get there. You're trying to see what's going on with your app. Well, let's tell you what's going on. Let's see why we're getting all of these HTTP 500 errors. And then finally, when you're thinking about, hey, I used to use something like IPsec back in the day. Where do I get that today? Well, this exists natively inside of a service mesh, and it's normally called something known as MTLS or mutual TLS. So TLS encryption from the world of HTTP, from our browser to that website, has made its way into the world of service mesh because all of our services that talk to each other, we need to trust them. We need to verify them. We need to make sure we authenticate them before. So, because if we don't, then comes the security problems. We haven't trusted any of these services. We don't know what they're doing. They're producing results that we don't expect. Have we been infiltrated in some way, shape, or form? So this is where service meshes really provide a lot of value because you're now addressing your security from a defense in depth point of view.
That's really interesting stuff. That makes a lot of sense to me because we do need a new way to kind of understand where things are going. And what was the old joke I heard someone say in IT? We believe that one new layer of abstraction can solve all our current problems. So we're always kind of creating layers of abstraction. But Sarbjeet, what do you think about that? I love this sort of mesh network concept for being able to handle these diverse needs and these spikes and hills and valleys and so forth. But what are your thoughts?
Yeah, my thoughts are that because of the sheer number of containers and the microservices running on top of it, I think that creates a lot of complexity, right? So how do you manage that complexity? Do you have your arms around your environment? Do you know what's happening in your environment? Do you know what's safe? I mean, you can't secure something which you don't know if it's there or not, right? So you have to have the discovery, you have to have grip on what you have. Only then you can secure those endpoints. And so that's the key, I think, in service mesh gives you that facility, if you will. And still on top of the service mesh, we still need to do more work to simplify it. So the certificate management at that level, at that speed, what certs are expiring and are we replacing those? And as Marina said, that the failure of node is assumed for, and that's the simplest definition of cloud native application is the failure of node is accounted for. So if a node fails, like, we don't care. It's a pets versus cattle discussion. You can Google that, or viewers can Google pets versus cattle. A famous blog from a VMware employee went viral around this topic. So yeah, and we don't treat our current servers as pets. They are like cattle. We can just kill them. We don't care, So that has implications. That where do we keep the state? Where our credentials are, like, of the people, and who has access to what, so all that stuff needs to be managed, and service mesh gives you that facility, and it will get bloated for some time in the near future, and then we'll clean it up and then bring something else, as you said, Eric,
Right.
that we love creating abstraction layers, and we will create another abstraction layer on top of it. And
Right.
there are a bunch of new projects actually under CNCF which are trying to do that.
Yeah, and that's a great point. So one of the cool things that maybe a lot of people in the business world don't know is just how prevalent the open source mindset and community has become in software development, which is great because in open source, we can all see the source code, right? We can kind of examine and understand, and thus, what's the old line? Well, there's an old cliche, many hands make light the work, and I say many eyes make few the errors. One of the cool things about open source is that bad code tends to go away, at least to a certain point, right? I mean, there is a bit of an argument about, the open source community bringing things only so far, and then that's why you have a Confluent sitting on top of Kafka. That's why you have, Cloudera sitting on top of Hadoop and that kind of thing. But Marino, I'll throw it over to you. I think the bottom line is that the openness of the environment is probably best in the long run because we can all see what's going on and navigate and understand, even though the bad guys can see what's going on too. What do you think, Marino?
I absolutely agree with that. So I think the complete transparency that open source has offered has allowed us to arrive at the fact that Kubernetes could become a cloud OS. It's because you've allowed players from IBM, from Azure, from
Right.
AWS, from Google, from every company to come in and provide a perspective to make it work for everyone.
Right.
And so you decide, okay, I want to deploy the same Kubernetes environment with my apps here on IBM Cloud, and then here on AKS, or even EKS for that matter, or even Civo Cloud. And the experience shouldn't be different at all. It should be the exact same. But in order to enable that, you really need to think about the right level of networking. So you can't just throw Kubernetes, expect a distributed system to work, and then move on with your day. You actually need to marry Kubernetes with an observability system, with a SIEM tool, with your service mesh, so you can tie it all together to treat it like one platform. But the reality is though, open source won't give this to you. Open source can't give this to you because they'll give you tiny pieces. And this is where you follow the breadcrumbs if you find an enterprise company. Now, the interesting patterns that you're going to see now is a movement towards internal developer platforms driven by platform engineering teams.
Oh, wow. Well, let's pick this up after the break. That's a nice
Certainly.
new thread we could dive into, folks. Don't touch that dial. I'll be right back. You are listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
On DM Radio, talking all about Kubernetes with Sanjay Johal. I'm sorry,
Sarabjit.
Sarabjit Johal. I've got a friend Sanjeev Mohan, friend Sarabjit Johal, another friend Sanjay Brahmawar I'm talking to.
Man, these Indians.
They're smart. They focus on STEM, right? They focus on science and math, and they learn stuff in schools and stuff like that. It comes in handy down the line if you've studied some math and some engineering, instead of just all these social studies experts in America here. But we're doing fine. We're having fun talking about Kubernetes. And before the break, Marino Vijay was talking about this shift that's taking place, DevOps versus sort of platform engineering. Tell us a bit about that and what you see happening.
So I don't think anything has necessarily changed from a job function standpoint. I think folks will still continue to work with the same set of tools, the same set of problem sets and whatnot. But I think what really ends up happening is how we bring all of these different pieces together under a singular platform that we can have complete visibility over. This is nothing new. I mean, companies like VMware and Red Hat have been doing this for a long time. And when you really think about it, you hop on GCP, that's basically a platform. So, when you think about the idea of platform and then engineering, all you're really doing is taking all the different tools that you normally would run to support your application and then just tying them together for easier integration all throughout. But the other side to that is, okay, you've built this platform, you have a platform available for folks to consume. Who's consuming that? It's developers. So these developers need a good, easy way to consume resources that you would have provided to them through this platform. And the best way to do this is offer up a developer portal where they can see and catalog tools that they might use. They can see their applications deployed. They can tune them the way they want. And really on the back end, it's a lot of automation working with tools like, or technologies like GitOps and using version control to make this all possible. So when you really think about, could Kubernetes become the cloud OS? Technically, you're right. This is absolutely the case, but it really falls back to practices and people. How do they go about building these platforms that allow or enable Kubernetes to become the cloud OS? And effectively, you're going to see a lot of companies doing this today. Solo will take one approach, offering it from the application lens or application networking lens. You'll see companies like Humanitech that offer it from the developer lens. And so there are companies really working hard to make sure that they provide an easy platform that operators and platform engineers can engage with, modify, curate to the needs of their developers, simultaneously allowing developers to deploy their apps very freely and easily, and even test them in any cloud environment, which is phenomenal because the agnosticity is what's going to become very important. And it actually is already happening. It's been happening for a long time. It's not perfected yet, but Kubernetes has enabled it. Kubernetes has become the catalyst to make that possible. So when you think 3 years from now, no one's really going to know that Kubernetes is there. In fact, no one's ever going to interact with Kubernetes. They're going to interact with a platform that'll interact with some layer that will interact with maybe Kubernetes or another manifestation of it. And that's what's going to happen. But I think we're learning from what Kubernetes has offered us to be able to get to that next stage.
Yeah.
And here I'll throw in this additional piece here. So with AI coming in, right? AI is doing a lot of great things for us. It can be concerning in a lot of different ways as well, because there are some inaccuracies, especially when it comes to the data sets being used. I mean, we're talking about data that lives back from 2021, September, if we're talking about ChatGPT, for example.
Right.
However, if you can manipulate parts of this AI system and maybe marry it to Kubernetes somehow, you can make this an effective tool to better understand what's going on in your multi-cluster Kubernetes environment. So there's a tool here that I'll just mention. It's something that a friend of mine built called, his name is Alex Jones, and he built this tool called Kate's GPT, which is effectively a powerful tool for SREs, DevOps engineers, platform engineers, to help them understand what's going on in their Kubernetes environment. It's like a chat buddy, chatbot. Hey, Kate's GPT, tell me why my services aren't being connected to. And then Kate's GPT is going to look for incomplete configuration. It's going to see if there's misconfiguration, just something that you wouldn't identify pretty easily. And that's pretty powerful, in my opinion.
Yeah, well, here's what I've been thinking about, right? Which is that, and ChatGPT, I've been following it for a while. Obviously, a couple months ago, we all kind of dove in and tried to figure out as much as we could. But one of the first observations I had was, and this is before I knew it could write code, I thought to myself, wait a minute, if it can write in German and French and Spanish and all these other languages where you have tens of thousands of words and all different kinds of syntax and grammar, et cetera, which are, pretty difficult to understand, but are rules. Like there are basic rules in syntax for languages, and we've been able to kind of abstract those out with these large language models. But I'm like, if it can write in these languages, it can write in code. And the answer is yes, it can write in code. And the other thing I thought, I'll throw it over to you, Sarvjit, and then maybe to Marino as well, is if you think about the intercommunication between machines, so machine data going from the server to the client to the cloud to the edge, all this stuff and all these different applications. Yeah, there are lots of permutations, but there are not so many permutations that it's more complex than a human language and the syntax and the grammar of a human language, which tells me that these engines should be able to do a pretty good job of understanding the orchestration that's going on in these very complex environments and be able to solve things just like Marina was suggesting, that it can say, oh, yes, this configuration is wrong, that configuration is wrong. I have to believe that's going to be possible. And I think a lot of companies are trying to use ChatGPT right now to do that very thing, which is basically like customer service or customer support in the form of a large language model acting like your helper. But what do you think, Sarvjit?
I think it's the best thing they can do, actually, and it's doable. Okay, if you notice what ChatGPT 3 was trained on, it was trained on the first training data was Amazon reviews. Seriously.
Really?
They use Amazon reviews data to find out what's the next character or what's the next word it's going to be in this set of text. That's what ChatGPT does actually at the basic, where you core level, it tries to predict the next word. After that, there's some mechanisms to the self introspection, what it's looking at, and the context and all that stuff, context building, which I talked about like 5 years back, that we need to have the mechanism of context injection into AI if we want AI to work, because you have to inject the context into the text. Otherwise, text can be a word can be said in so many different sort of contexts, right? So yeah, we can do that, and we have done a lot of analysis of logs. The company's Log4j, and Log4j was the APIs and all that stuff. That was a troublesome API, but the companies like which and help you analyze log, like Splunk and many others, their competitors, like they were looking at the patterns in the logs, right? And then with the help of large language models, we can unleash that power on the logs, I believe, because logs are very sort of, they are not that precise, but at the same time, they are between human language, which is very loosey goosey, and the machine produced consistent data, if you will. So they're in between. So we can, I think, leverage AI in that context to get a grip on what's going on in these different environments, and if we are lacking in security in certain areas, if there's certain ports which shouldn't be open and stuff like that. So we can do a lot there, yes. And just to comment on the previous thing what Marino was talking about, the DevOps versus the platform engineering. The key is that what DevOps encouraged was two pizza teams, right? So you have dev and ops in one team, right? So what that did was it skewed the ratio of the ops to dev. Traditionally, when we had the waterfall models, when we were writing software for 6 months and we deploy it, and then we write for another 6 months or 3 months or whatever that period was, waterfall model, there were a bunch of teams developing software, but operations team was one, right? There was one to many relationship between dev and ops, right? But then we skewed that, so that ratio was made kind of skewed, and then we were wasting some money there, actually. So we need special, the whole idea behind industrialization of any discipline is like you are specializing in different functions. So we need a specialized function where all these ops are kept with one sort of most of the in one area, and that's what the whole idea behind platform engineering is. So you can put all the shared functions in one bucket in one team.
Yeah, no, that's a really good point. And then we talk about silos and organizations and breaking down the silos of the data, but also the people and the functionality, et cetera. And it's always going to be a mixed bag, right? You're going to kind of swing this way, then swing back that way. But the point is, we want people working together. We want people to have visibility to what's getting done. That's the key. Podcast bonus segment is coming up next, folks. You've been listening to DM Radio.